Hey everyone, let's talk about 3D organ printing. Over the past several decades, the demand for donor organs has skyrocketed. However, the supply for these much needed organs has not seen the same growth, leading to long wait lists. It's estimated that about 18 people die each day waiting for an organ they will never receive. To address this issue, biomedical engineers have been working over the past several years to use 3D printing technology to actually print living tissues using specialized printers. Currently, researchers are able to print scaffolds on which living cells will adhere and grow. These scaffolds may be made from a variety of materials, the most common of which are hydrogels. These hydrogels need to stimulate the microenvironment of the cells that will grow on them, and have to be able to safely break down after being transplanted into the body. Now, these hydrogels can be made from several different chemicals and are generally divided into two categories: synthetic, which is usually made of polymers of polyethylene glycol, or natural, which are made from naturally occurring polymers like collagen or fibrin. Each type has its own benefits. For example, synthetic structures are easily manipulated and tweaked in the laboratory, whereas natural polymers are less likely to be rejected by the body, and cells can easily adhere to them because they contain the naturally occurring ligands that are found in the human body. The printer places these structures in the desired pattern, and then they have to be polymerized to form the tissue. Methods of polymerization vary, but one of the most common is the use of photo-cross-linkable side groups such as thiols and aldehydes that utilize light energy to bind together. Living cells can then be embedded in the scaffold, allowing them to proliferate and differentiate to form a functional tissue or organ. So is this all theory, or is there an actual application to this technology? As a matter of fact, researchers have successfully been able to create simple tissues and organs that can be used by human patients. These include skin tissues, small blood vessels, and even urinary bladders. The next step is working on slightly more complex organs. One of the examples of this is aortic heart valves. Patients with aortic valve disease typically must undergo valve replacement surgery. The replacement valve can be completely synthetic structures, porcine, or from a donor, but issues exist with all three, leaving 3D bioprinting as a promising alternative. Researchers have been able to print a functional valve that matches the geometry and structural fidelity of a human valve. And, with further testing, it's likely this valve can be transplanted into patients. The major problem facing bioprinting is the difficulty of printing big organs such as kidneys and livers. So far, small livers and kidneys have been made, but they are currently used for pharmaceutical testing rather than transplantation. And although researchers predict it may be years or even decades before such complex structures can be easily printed, 3D bioprinting remains the most promising solution to the donor organ shortage we face today. Thank you for listening, and here's a picture of a mouse with an ear growing out of its back.